What's going on, math people? We are back, and tonight we are going to be working on derivatives as a rate of change. Now, we already done went through what a rate of change is. We went through average rate of change, and we knew that was changing something in the numerator over the change in something in the denominator. So let's look at derivatives as a rate of change. All right. So let's jump into this thing right here. We have change in S. S in calculus stands for position. That's your starting position. All right, so this says the change in position. So change in position over the change in time, change in position over the change in time gives us average velocity. This is average velocity. All right. Now, another word for change in position, if you want to get all fancified, that word would be displacement. Displacement. All right. So, calculating displacement, you're taking the change in your starting position and your ending position with respect to the times. All right. So, but look at this. You remember when we first started talking about average rate of change and we said, oh, that was slope. And can you see that this is a slope? And what do we also say is slope? Slope is also the first derivative. So what we have identified right here is that average velocity, which will be denoted by this v of t with respect of time, is equal to ds dt, which is the change in position or the change in time or displacement over time. All right. So, and let's roll on to an example, shall we? Before we jump into an example, let's just toss in all this derivative information first. All right, so we have average velocity. 1. 2. What if someone says, what is speed? Speed is the absolute value of velocity. So that says that speed will always produce a positive value. Velocity can be positive or negative depending on the direction, but speed will always be positive. Okay? 3. The second derivative of velocity is, well, the derivative of velocity is acceleration. Acceleration is equal to v prime, or the derivative of velocity. And that would be dv dt. So, second derivative is acceleration. And finally, if you take another derivative, that would be called jerk. The derivative of acceleration, is jerk. All right, so let's put this thing into work. And let's say we have a dynamite blast. You know what? Let me get y'all an even better example. Let's make sure you know how to calculate displacement. So how about we do this? I want y'all to pause for a quick second while I get you a nice super duper example, because I love you, okay? So I'm gonna go ahead and jump on this example for you. I'm pulling it up. But while this is pulling up, I'll give you a nice little corny calculus joke. All right? So if someone is being obnoxious, it's like, look, please don't be a third derivative. Get it? A jerk? Okay. Okay. All right. You don't have to laugh. But anyways, all right. We're almost there. All right. Let's look at this. All right. So we got ourselves a nice little example here. And suppose, let's say, a body is moving with position S of t is equal to t squared minus 4t plus 3 on the interval, on the given time interval of 0 to 8. All right, so first thing first, it also gives us our measures. It says S is in meters and T is in seconds. All right, so it says find the body's displacement and average velocity. All right, so to find displacement, we know displacement is the change in position. All right, so in order to find the change in position, we have to find the position at the time on the time interval. So we have at the ending time, S of h is equal to 8 squared minus 4 times 8 plus 3, and what do we get? So we have 64 minus 32, that's 32, plus 3 is 35. All right. Then at the starting position, we have 0 squared minus 4 times 0 plus 3. That gives us 3. So the displacement is the difference in those numbers. So the displacement is equal to 35 minus 3. The distance traveled from time interval to time interval was 32 meters. All right. All right, so it traveled 32 meters in that 8-second time span. And the problem also wants us to find the average velocity. All right, so we know that average velocity is equal to displacement over the change in time. So we know that the displacement is 32 meters. And the change in time, the ending time was 8 seconds. Starting time was 0. So that gives us 32 divided by 8 equals 4 meters per second. Okay? So that took care of that. It says find the body's speed and acceleration at the endpoints of the interval. Okay? Find the body's speed and acceleration at the endpoints of the interval. So what we'll do is go ahead and we know that speed is equal to the absolute value of velocity. We know that. It wants us to find the speed and endpoints of speed at the endpoints. So we're going to calculate velocity. Velocity is equal to the first derivative, which is 2t minus 4. All right, so if we want to find the speed at the endpoints, we have absolute value of the first endpoint is 0. So that's absolute value of 2 times 0 minus 4 equals absolute value of negative 4. So the starting speed is at 4 meters per second. And the next one, I didn't mean to put that. I guess I can change up this color so that the other endpoint, V of 8, we have 2 times 8 minus 4 equals 12. So the absolute value at the other endpoint, the speed at the other endpoint, it had picked up a little speed as moving at 12 meters per second by the time it gets to the end. Finally, it says find the body's acceleration at the endpoints. Now we know that acceleration is the derivative of velocity. So acceleration is equal to 2. Since the acceleration is a constant, the acceleration is going to be consistent throughout. So at the endpoint, at 0 seconds, the acceleration is 2. At 8 seconds, the acceleration is 2. All right. And finally, it says, when, if ever, during the interval does the body change direction? All right. The body changes direction. The body changes direction when the velocity equals 0. All right. So when the velocity equals 0, that's when the body changes direction. So we're going to take our velocity, set it equal to 0, and solve and see at what time the body changes direction. So we have 2t minus 4 equal to 0. Solving for t equals 2. So after 2 seconds, the body changes direction. All right, my math people, that's our